talk about a few things dealing with Cramer's rule. Before I get to Cramer's rule, though, let's talk about what a determinant is, or how to find it, and then later on how to use it. So a determinant of a 2 by 2 matrix, there's a couple of ways that I can symbolize a determinant. You'll notice that for this example, I have used things that look like absolute value bars. You'll notice that later on down in number 2, it could look like not absolute value bars, but just DET for determinant with my normal matrix brackets. So either one is okay here. If I wanted to find the determinant of this example matrix, what I would need to do is I would need to multiply on the diagonal. So I would need to multiply A times D, and then I will also need to multiply B times C, and then I will subtract those two products. So you'll notice A times D is my first diagonal minus B times C, my second diagonal. If you have to find determinant of a bigger matrix, you're going to use the calculator for that. And for the record, you can only find the determinant of a square matrix. So notice I've only shown you a 2 by 2 and a 3 by 3. We'll try the next one during class. The second thing that I want to talk to you about is Cramer's rule, and I'm just going to set up the requirements for Cramer's rule. Remember, this is the fifth method of being able to solve a system of equations. So you'll see here that I have an example system of equations. I've just used variables in here. I don't have any actual numbers. We'll do that in class. But we're going to very first turn our system into matrices. So you'll look at what I have written here. I have a normal D, which is my normal determinant. I have a D sub x, which is a determinant dealing with x's, and then I also have a D sub y, which is a determinant dealing with y's. So let's look at how to find each one of these. If I want to find a normal determinant, then I'm only going to use the coefficients of my x's and my y's. I'm just going to use my coefficient matrix. So you'll see here that I'm going to find the determinant of my coefficient matrix. We understand at this point that this means I'm going to have A times E minus B times D. If I want to find the determinant sub x, then what I'll do is I'll take out the x coefficients and replace them with the constants. So you'll see that I totally left my y coefficients alone, but my x coefficients were replaced by the constants. So if I'm going to find the determinant here, this will equal C times E minus B times F. And then to get my determinant sub y, it's the exact same type of idea. Take out your y coefficients, replace with the constants, leave your x coefficients alone, the original x coefficients. And if I'm finding determinant here, this will be A times F minus C times D. So that's how you find those three specific determinants. Now, what do you do with them? Remember that to solve a system, we're looking for where my graphs cross over each other. My solution is the intersection of the graphs. So you'll notice I've got my coordinate already set up. So my solution, the x piece of my solution, is going to be determinant sub x divided by the plain old determinant. The y value of my solution will be determinant sub y divided by my plain old determinant. Come back and we'll talk about number 58 in class, and we'll find a solution using Cramer's rule.